Hey everybody, in this video we're going to be doing some transformer questions. Our first question is, a transformer has a primary with 240 coils and a secondary of 720 coils. If 24 volts of AC is connected to the input terminals, calculate the output voltage, assuming that there's no power loss. For this question, we can just use our equation for transformers, where our voltage of our secondary divided by the voltage of our primary is equal to the number of coils of the secondary divided by the number of coils in the primary. We can rearrange this equation, just moving the voltage of the primary over to the other side, gives our voltage in our secondary equal to the voltage of the primary times by the number of coils in the secondary divided by the number of coils in the primary. Now we can just plug in our values for this. So the voltage in our primary is 24 volts. We have 720 coils in the secondary and 240 coils in the primary. This gives us 72 volts. On to the second question. A transformer is connected to a domestic 240 volts AC supply. If the required output voltage is 12 volts AC, calculate the ratio between the number of primary and secondary coils. In this situation, we're after a ratio, but we're after a ratio of primary to secondary. So I'm going to look for number of primary divided by my number of secondary. Putting in the rest of the equation, this is going to be equal to the voltage of the primary divided by the voltage of the secondary. Now we can just chuck in the numbers. So we have 200 volts as our primary, and we have 12 volts as our secondary. Simplifying this ratio, we get 20 divided by 1. This means that for every 20 coils of the primary, the secondary is only going to have a single coil. On to our third question. A power company produces 500 megawatts of electricity at 0.12 megavolts. If the total resistance from the wires connecting to a town is 4 ohms, how much current flows at the power station? For part A, we only need to know that power is equal to the current times the voltage. Rearranging this gives current is equal to power divided by voltage. Now we can just substitute some numbers in. We have our power equal to 500 megawatts divided by 0.12 megavolts, which gives us 4.2 times 10 to the 3 amps, or 4.2 kiloamps. Part B. What is the percentage loss of power in the cables? Well, now that we know the current, we can use this current and figure out how much power is lost due to that resistance. In our videos, we learnt that our power loss is equal to the current squared times by the resistance. We just determined what our current was, and we know what the resistance of the wire. So we can just substitute those numbers in, which gives us 69 times 10 to the 6 watts, or 69 megawatts. However, the question asks for a percentage, so we need to figure out what percentage of that of our original production is lost. So we just do 69 divided by 500 times by 100. And this gives us 14% as lost power. Now on to part C. If the power company transmitted at 0.08 megavolts, what would be the percentage of power loss? First, we need to determine how much current is actually being produced now at the power station. So again, our current is equal to our power divided by our voltage. Now we can just substitute the numbers in, so 500 times 10 to the 6 divided by 0.08 times 10 to the 6. And this gives us 6,250 amps. Now we need to figure out how much power loss we have. So again, our power loss is equal to our current squared times by the resistance, which we can then substitute those numbers in, which comes out to be 156 megawatts. So now we just need to determine the percentage loss. So 156 divided by 500 times by 100, which gives us a percentage loss of 31%. So from this we can see that it is actually a lot better to have a lower current through our wires as it gives less power loss. So in summary, this video just went through a couple of questions using our formula for transformers, as well as some of the information that we talked about, power and power loss. Thanks for watching. See you in the next video.